So we saw what is the condition for central maxima, then we saw for dark spot. Then you have a maxima again, maybe with a lesser intensity. This point has to be in mind. Compared to the central maxima, the other maxima is going to have lesser intensity. So keeping this point in mind, condition for, see, I'm going to use the word concentrate. Condition for first secondary maxima. So any maxima other than the central maximum is called as the secondary maxima. But now we are going to discuss about the first secondary maxima that is being formed on the screen. Is that clear? Now see, the explanation is, so for us to explain the central spot, how many parts did we break the slit into? For explaining the central bright spot, that is the central maxima, I'll put it like this, central is not maxima, maximum. So for central maximum, the slit is broken into how many parts? No, here you see. For central maximum, it is only one. I never broke it. For central maximum, yes, it is one slit. For first minima, we broke it into two parts, two equal parts. So for first secondary maxima, we are going to break it into three equal spots in such a way that the rays which are coming, what will happen to them? That is the question. So all the rays will get bent, and the distance between each slit is how much? D by 3. Right. So if this is S1, S2, S3, and S4, between S1 and S2, I can find one ray. Let's say it is going to point P dash. If this ray is getting bent by an angle theta 2, between S2 and S3, you can find a ray which is exactly symmetric to the ray which is coming from the first, that is between S1 and S2. You can find an exactly symmetric ray to this. Between S3 and S4, you can find another ray which is exactly symmetric, such that all the rays will get bent by what angle? By the same angle, theta 2. Right? Right? So, but one point should be clear. How many openings are actually there? There is actually only one opening. All these things we are breaking into different parts only to give a theoretical explanation to it. Okay. Now tell me one thing. I'm changing it, see. I'll take this as S1, S2, and S3. Okay. Now, what explanation are we trying to give? We are trying to give the explanation for secondary maximum. First secondary maximum. So the condition for maximum, we know it is odd multiples of lambda by 2. Right? The path difference has to be odd multiples of lambda by 2. Now concentrate, guys. I am saying S1 P dash and S2 P dash are undergoing, don't write, concentrate, are undergoing constructive interference, and S3P dash is further undergoing a constructive interference. At which point? At point P dash. So what I'm trying to say is S1P and S2P are traveling in such a way that these two are going and falling on the screen and forming what kind of a spot? So ray from S1 and S2, they are going and falling on the screen P dash. By undergoing constructive interference means what is going to happen?
Right.
What spot?
Right.
You will find a bright spot. Okay. And the third ray is there. The third ray is actually going and falling on the screen P dash to add some more light to it. My question is this possible? Because see, we are again trying to give an explanation. I'll give you some hints. Think in those terms. See, it's not like I'm just coming up with some random theory. You are able to see what is happening on the screen. And I was stressing on one important point. What is that? I was stressing on one important point, that is the intensity of light. Right? So I'm talking about intensity of light. Now think of the theory that I've given you. I've told you that S1P and S2P both are meeting in such a way that they undergo constructive interference. When constructive interference is taking place due to two light sources, at the point P dash, will you have more amount of light or less amount of light?
More amount of light.
You will have more amount of light, means you will find more intensity. So to the already existing amount of light, if S3P is also going and falling on S3P dash is also going and falling on the screen such a way that it is adding some more light to the already existing one, then the spot at P dash will become more
Intense.
Brighter.
intense. But yes, it would have become more brighter. But what is it you're able to observe on the screen?
The intensity will decrease.
Intensity is less compared to whom? Compared to the central
Central
maximum.
bright spot.
So what change is going to happen is the rays from S1P dash and S2P dash will undergo what interference? Destructive interference, and S3P dash is further undergoing a constructive interference at point P dash. This is what is going to happen. Now think of the logic. If S1P dash and S2P dash are going and meeting on the screen in such a way that they're forming a dark spot, so now have in your mind, from S1P and S2P, the lights have got cancelled out. So what is it? What is there on the screen? You have a dark spot. To the existing dark spot, if there is some amount of light that is coming from the third slit and going and falling on the screen, what would have happened?
Bright spot will be there.
You will have a bright spot, but a less intense one. Is that clear? Does it make sense? So
Yes.
what we are trying to say is the rays coming from these two parts, that is these two portions, will undergo destructive interference, and the ray that is coming from the third part alone will contribute to some amount of light on the screen. That is the reason why we are able to find the first secondary maximum on the screen. Okay. So this is a very, very, very important point. Please make a note. S1P dash and S2P dash will undergo destructive interference, and S3P dash will undergo constructive interference at point P dash. And if you ask me if this is possible, yes, it is possible. Okay. Now comes an important point. This one. S1, S2. I'm drawing a separate diagram. S3. What is the distance between S1 and S2?
D/3.
Yes. Okay. So this is S1 and S2. The rays are getting bent such that this is theta2 and this is also theta2. You have a point P which is falling here, P dash. Okay. Now observe. You are able to find the bright spot on the screen at point P dash only because of the fact that the rays from S1 and S2 are undergoing what? Destructive interference. Again, now look at the mathematical condition I'm going to write. Condition for first secondary maxima or maximum is path difference between S1P dash and S2P dash should be, can you guys tell me how much?
Lambda by 2.
Very good. Should be lambda by 2. And the reason is they are subsequent rays. The path difference between the subsequent rays is supposed to be lambda by 2. So it is because here it is lambda by 2, we are able to say that we are able to find a bright spot on the at the point P dash. So here, one important point to be noted in the case of diffraction is whether you talk about the first secondary maxima or minima, nowhere you will use the condition of constructive interference at all. You will always use the condition of destructive interference. Okay, so what is the path difference, guys? If I drop a perpendicular, if this is theta 2, it's similar to the previous case. So path difference will be d by 3 times sine theta 2 is equal to lambda by 2. Accepted?
Yes, sir.
So what should be the value of d sine theta 2? That should be 3 lambda by 2. So this is the condition for what? For the first secondary maximum. This is a mathematical condition. D sine theta 2 is equal to 3 times lambda divided by 2. This is the condition for first secondary maximum. Make a note.